Welcome to Spring LIB.
In this problem, we're asked to consider 4 ionic compounds: lithium fluoride, sodium chloride, potassium bromide, and rubidium iodide. The measured cation-anion distances are 2.01 angstroms, 2.82 angstroms, 3.30 angstroms, and 3.67 angstroms. We are asked to, for A, predict, let's do this. Got a dog barking, sorry. The cation-anion distance, I should say. Using ionic radii data from your text. So I looked up the atomic radius for each one of these ions. And when I looked up lithium, it is 0.90. These are all in angstroms, but I'm in the effort to save some space, I'm going to leave the angstroms off. When I add these, I get 2.09 angstroms. Pretty close. For our next one, I looked up sodium. I got 1.16 and 1.67. Again, we just look up these values, and I got 2.83. $1.52, 1.82, 3.34, and finally 1.66 plus 2.06 to 3.72 angstroms. These are calculated using ionic radii from the text. Next, for B, let's make this a nice bright red. We're asked to say if this agreement, is the agreement perfect? And of course the answer is no. We can see that it's not perfect. If not, why? The ionic radii that's listed in the tables are averages. There are many factors that can depend what will the actual measured cation-anion distances will be. For instance, chlorine will behave differently when it's bonding with potassium, lithium, or sodium. It won't behave the exact same. The value in the table is from the average of all the chlorine bonding. Let's go to a green. For C, we are asked to estimate the cation anion distances. Again, I said that wrong. using atomic radii as opposed to ionic. So we're going to do the same thing, but this time I'm going to use atomic radius. And these again will be in angstroms. And let me get started on that. I have 1.34 plus 0.71 equals 2.05. Next, I have 1.54. Oh, no, no, that's right. 1.54 plus 0.99 2.53 angstroms. Next, I have 1.96 and 1.14 for 3.10 angstroms. And finally, I have 2.11 plus 1.33 for 3.44 for angstroms. Are these estimates as accurate? So are the C values as close to the measured values provided as the A values? In other words, which are closest? Or shall we say, which are best? Ionic or atomic radii? And let's take a look. I think I'll highlight with this peach right here. And first, let's look at lithium. Here's my three values. And for this one, the better of the two for A and C is C. Let's take a look at this one. The better is A by far. The better is A by far. And the better is A by far. So the best estimate is ionic. We're done.